produits que nous sommes sur le point de lancer et leurs applications dans le monde entier. Ces 3 nouveaux produits représentent également les dernières tendances dans les domaines de l'accès aux transmissions optiques. Premièrement, suivons ensemble M. Gu Yongbu, vice-président de la gamme de produits entreprises de transmission and Access, qui va présenter la dernière technologie de transmission optique Liquid OTN.
The electric power industry is now digitalizing its OT system. This means a larger scale in producing traditional and clean energies, increasing automated devices and surveillance devices, and more exchanges of OM data. Some enterprises have even launched new operation service. At the center of the electric power communication system, the power transmission and transformation communications network is facing new challenges. First, providing security for production automation and operation. For example, teleprotection requires dedicated paths to ensure high reliability and low latency. Second, delivering system compatibility for different service interfaces. Third, handling 100 times more traffic due to the digital office, new service operation, and cloud-based data center construction. Fourth, managing the scale development of distributed power generation and longer distance of EHV power transmission. In the past, PDH and SDH supported the informatization and automation phases respectively. Now, Liquid OTN is the best choice for next-generation power production. Like previous technologies, Liquid OTN has physical isolation, optimal latency, and perfectly suited production devices. What's more, it provides more scalable bandwidth. Liquid OTN offers a secure, reliable, efficient, scalable, and energy-saving guarantee for production communications. What's Liquid OTN? Liquid OTN is the next-generation hard pipe transportation technology inherited from SDH, providing highly secure pipes for OT networks. In addition, Liquid OTN is an advancement based on SDH. First, simplify the service mapping path. Traditional SDH service mapping paths at least 3 layers. Liquid OTN only needs 2 layers. So, the latency of a single site is reduced to less than microseconds. Second, adopting converged barrier technology. Liquid OTN supports 2 megabit to 100G any rate interfaces, reducing device tips and simplify network layers, discounting TCO by over 30%. In addition, Liquid OTN provides hitless and lossless adjustment from 2 megabit to 100 giga, reducing bandwidth fragments and improving utilization to 100%. SDH only provides 10G bandwidth with a single fiber. By using Liquid OTN, a single wavelength can provide 100 giga and above. A single fiber can provide more than 48 terabit. With insights into the electric power industry and optical technologies, Huawei develops a simplified, secure, and smart communication solution based on Liquid OTN. This solution offers a 4-in-1 platform that adapts to multiple scenarios, in addition to old and new interfaces. It integrates the traditional production, office, and bandwidth operation networks, reducing TCO by 30%, and these services are physically isolated to guarantee security. Moreover, solution inherits SDH mature achievements, including hard pipe and ultra-low latency, so that to guarantee teleprotection working safely, the 450 km single span and intelligent unified O&M reduces hardware investment and improves overall O&M efficiency. A power communications network carries production services such as teleprotection, SCADA, dispatching telephone, video surveillance, information storage, and data center interconnection. Its rate ranges from 64 kbit to 100 giga. Traditional multiple types of devices are stacked, and the transmission devices such as PCM, SDH, packet, and OTN are used to carry production signals. To address this, Huawei's new Liquid OTN platform provides unified service switching capabilities by integrating SDH, packet, and OTN cross-connect plays. Varied service boards support different services, and the intelligent universal libraries implement universal transmission. This means the capabilities of multiple devices are integrated into one. As such, device management is simplified. Cabinet space is saved by 70%, and the device power consumption is reduced by 50%. Overall, this means that the TCO can be reduced by more than 30%. OT networks have high requirement on security and reliability. For teleprotection, if a system fault is discovered, faulty components must be removed automatically, quickly, and correctly. In this way, damage to power components and the impact on system security are both minimized. Liquid OTN is a hard pipe technology, similar to SDH. Compared with IP soft pipes, hard pipes provide dedicated bandwidth to carry signals. This means there is no interference between pipes. In addition, low latency is guaranteed, deterministic, and visualized in an end-to-end manner. This ensures high security and reliable response of OT network services. As a leader in the optical industry, Huawei introduces ultra-long-haul transmission technologies to electric power networks. With high-rate optical modules and unique CMS algorithms, Huawei delivers 20% longer transmission distance compared to the other vendors. In fact, the transmission of a single span can reach up to 450 kilometers. This perfectly matches set deployment and maintenance in unattended areas, such as deserts and forests. The next generation power network solution based on Liquid OTN perfectly matches various application scenarios and challenges. The 4-in-1 interfaces can access narrowband, HD video, and high-speed Ethernet data. Hard pipes ensure low latency, stable reliability, and security for transmission networks. The ultra-large transmission capacity provides bandwidth support for new O&M and operation modes. Superb transmission performance effectively reduces UHV O&M costs. Huawei's Liquid OTN-based OptiX Trans series covers the power backbone, transmission, and access network scenarios. The OptiX Trans E9600 series support 24 service slots and 48 T per fiber, making it suitable for backbone network transmission. The OptiX Trans E660 series features small-sized case-shaped products with reduced power consumption. They support AC and DC power supply and are easy to install and deploy, meaning they are applicable to metro aggregation and access scenarios. The next generation power communications network solution based on liquid OTN will usher in a new round of development in the power industry. Now, let's witness this historic moment. Thank you.
NG is solely owned subsidiary of SEC, responsible for power transmission and transformation services of more than 1,100 substations.
NG has made remarkable strides as driving force of global smart grid initiatives. Resultantly, NG has one of the largest fiber optic network in the region with coverage more than 70,000 kilometers. Network bandwidth usage up to 8 terabytes. In the road of these developments, we choose to work closely with Huawei to achieve fruitful results in the power grid ICT field.
NG was established in 2012. It has completed optical fiber architecture deployment during the past years, initiated network development and deployed huge optical network to provide the highly reliable telecom services for efficient operation of transmission network. NG strives to continuously improve and optimize production services, simplify the network bearer architecture of production services, and implement the transformation from TDM to packet networks that carry multiple services in a unified manner. As a leader in the ICT industry, Huawei has provided NG with a complete and mature technology evolution direction.
Huawei is among the first vendors to initiate the evolution path of ICT in National Grid Saudi Arabia. Our smart grid vision is focusing on digitally enabled infrastructure, in line with the global trend in grid modernization and business transformation.
As a corporate level strategic partner, Huawei also continuously support on knowledge transfer by conducting workshops, technical seminars, certified training, and joint innovation lab to align with National Grid's talent development strategies.
Today's Saudi Arabia, a country moving forward to become the heart of the Arab and Islamic world, is the investment powerhouse and the global hub connecting 3 continents. This is the Vision 2030. The National Transformation Program 2020 was launched to support the vision by developing governmental work and establishing the needed infrastructure. Saudi's digital transformation agenda is to build a fully connected, intelligent world in which every citizen can experience the best connection service. To achieve this, Saudi Arabia has 3 initiatives: 100% connection service coverage, 4G in rural and distant areas, and FTTH. Saudi Arabia has achieved a 100% connection service coverage throughout its grand territory and population by July 2018. Citizens can now get connected and keep up with the ever-changing world, even in the most distant area. Saudi Arabia is ambitious to build a fully connected, intelligent society by providing citizens with fastest internet connection, fiber. Fiber's connection is 10 times faster than 4G connection.
Dawiyat is a very unique company. It has been licensed by CITC, the Communication and Information Technology Commission in the Kingdom of Saudi Arabia, to offer wholesale services to the various operators, the various infrastructure telecommunication providers in Saudi Arabia. The Saudi Electricity Company has actually now surpassed 75,000 kilometers of fiber placed in the Kingdom of Saudi Arabia. This network is not only vast, but very robust.
Fiber connection will greatly enrich people's internet experience, bring new business models into reality, and boost the digital transformation of the country.
I think this is a fantastic step to take the telecommunications sector in Saudi Arabia to a new higher level.
The country is ready for future development. The next step towards 5G, IoT, and AI is on the way. In a fully connected, intelligent Saudi Arabia, innovation will be catalyzed and new potentials will be unleashed. Every person, group, and family will be able to fulfill their dreams and ambitions.
Merci Monsieur Gouyambou pour cette intervention très enrichissante. Avec les nouveaux challenges du moment, viennent inévitablement de nouvelles technologies et applications. Parlons de la première application de cette nouvelle technologie en Chine, New Liquid OTN, utilisée dans le SGCC avec Madame Hong Xianyang, directrice du département de technologie et de développement de SGCC.
Hello everyone, I'm Yang Hongzhen, Director of the Technology and Development Department of Zhejiang Electric Power Company of SGCC and Chair of the IEEE P2893 Working Group. Today, as a power industry practitioner and technical standard participant, I'm honored to share with you new OTN optical transmission technology helps build a converged and elastic grid. First, let me introduce Zhejiang Electric Power Company of SGCC. It is a wholly owned subsidiary of State Grid Corporation. It is tasked with building and operating the power grid. It is responsible for ensuring a safer, more economical, cleaner, and sustainable power supply. It is a key enterprise in the energy field in Zhejiang province. This company directly manages 17 units and 78 power supply companies, including 11 city-level and 67 county-level power supply companies. Its power supply services cover 56 million people in the province. The company has 57,000 kilometers of 110 kilovolt or above transmission lines and 433 million kilovolt ampere substation capacity. 31,000 kilovolt substations have been built, and the substation capacity reaches 18 million kilovolt ampere. It has deployed the world's first 500 kilovolt cruise-linked polyethylene submarine cable. Looking into the future, Zhejiang Electric Power Company plans to basically build a world-class modern energy enterprise with outstanding competitiveness by 2025, with the company's asset quality, operating performance, and service quality reaching the world-class level. By 2035, we will build an absolutely leading modern energy enterprise with outstanding competitiveness. The company's value creation capability, market competitiveness, and brand influence will reach the world-class level. In recent years, with the rapid economic and social development of Zhejiang, the demand for electricity continues to grow. The peak power consumption of Zhejiang reaches 92.68 million kilowatts, an increase of 8.82% over last year. It is estimated that this number will exceed 100 million kilowatts by 2021. With the growth of the peak power consumption for many years and due to power volume increase and power price decrease, the traditional model of expanding the scale to meet the growth of electricity demand is no longer workable. In Zhejiang province, there are 13 types of power supplies. Substation sites and line corridor resources are increasingly insufficient. However, there is huge potential for utilizing existing corridor resources. The power supply and power grid sites are trying hard to meet increasing power consumption demand, but users are not fully engaged. The energy storage side is constrained by the lack of conducive policies. Power generation, grid, load, and storage are not effectively linked. Market access, trading, and settlement mechanisms need to be improved. Power supply adjustment capability is decreasing. Security red lines are tightening. Load interaction mechanism is not mature. Energy storage facilities are insufficient and difficult to use. Power grids are facing problems of lack of interaction between generation and load, redundancy for security, decreasing balancing capacity, and lack of efficiency improvement methods. Therefore, traditional power grids need to transform towards flexible generation grid load storage interaction. Transform the power grid from load-based generation to generation load interaction, from redundancy for security to reduce the redundancy with the security, from power balance to electricity balance, and from efficiency reduction for security to improved security and efficiency. In the strategic framework of the state grid, we propose to build a converged and elastic grid for the energy internet. The purpose is to improve the traditional generation grid load storage model and support the grid to transform towards energy internet, which is based on big data, cloud, IoT, mobility, AI, and blockchain technologies. It aims to improve power grid security, operation efficiency, and overall energy efficiency by using technologies and market factors. A converged and elastic grid is key to the energy internet. Online energy production with transmission, distribution, and consumption enable efficient interactions, jointly activate underutilized power resources with customers, promote the transformation of power grids towards energy internet, involving users in load adjustment. That will greatly reduce inefficient power investment and energy consumption costs. To build a converged and elastic grid, technical enablement is an important implementation path. With 5G, optical connectivity, and IoT sensing technologies, power production, transmission, and consumption can be aligned. Use IoT, big data, AI, and other new technologies to build power IoT and cloud computing platforms to support diverse internal and external power service applications. Enable power grids to have high bearing capability, high interaction, high self-healing, and high efficiency. In the entire architecture, power information communication supports the control, management, and applications of smart grids and is the core element of the converged and elastic grid. Therefore, with the transformation and development of the electric power industry, information communication also needs to be upgraded to meet the requirements of grid construction and development. Currently, the power information communication network is seeing a sharp increase of power grid service traffic. First, increasing new energy and services. Solar and wind energy and other types of new energy is integrated to the network, increasing distributed power generation and storage. More digital technologies are applied in production, such as environmental monitoring, unattended operation, and IoT sensing, provide new power services for consumers such as charging piles and the smart home. Second, extending the control capability, expand from power transmission and transformation control to power distribution, distributed power supply, and power consumption control. The number of control points increases from hundreds of thousands to millions. Quasi-real-time control is enhanced to real-time control, and the control frequency changes from low to high. Third, explosive growth of data. Data collection points and collected data volume are increasing significantly. Data collection frequency and timeliness are improved. Meters and charging piles interact with the power grid, and the demand for massive data exchanges increases sharply. For example, by 2021, State Grid is expected to have over 1.2 million small charging piles. By 2025, over 1 billion devices are expected to be deployed. The daily incremental data collected on the entire network is expected to exceed 100 TB. As power grid service transformation leads to a sharp increase of information flows, the optical communications private network faces challenges posed by the power industry and the technology industry. For example, in the electric power industry, first, high security and reliability are required. The communication network must meet the national information security protection level, and the reliability must reach 99.999%. The requirements for relay protection are even higher. Second, the demand of diversified services must be met. The communication network must be able to carry traditional production dispatch, control, and monitoring services, as well as IoT sensing and data center services. Third, ultra-high bandwidth is required. The information traffic connected by massive devices on the entire network can reach dozens of TBs after being aggregated to the backbone network. From the technology industry perspective, due to bandwidth bottlenecks, traditional SDH technologies are unable to support digital information services. The SDH industry is shrinking, and older processing techniques are phasing out, and the entire communications industry is upgrading. The current OTN technology lacks small granularity capabilities. Bandwidth utilization is low. It cannot efficiently carry low-speed services and cannot meet latency requirements of key services. Therefore, the electric power optical communication is calling for a new technology. Through research, we believe that OSU Flex is the primary choice for power communications private networks. OSU Flex inherits the roadmap and the development direction of the traditional TDM technology, adding SDH technology features to the existing OTN technology. In addition, it inherits the technical strengths of SDH and OTN optical communication private networks, including small granularity service encapsulation such as 2 megabit per second, ultra-low latency assurance, 200G BPS bandwidth that supports expansion similar as OTN, and a unified bearing capability, one platform, one technology platform for multiple services, including PCM, SDH, and packet services. OSU Flex inherits the features of SDH and OTN. It inherits the feature of hard pipe physical isolation. Services of different systems can be transmitted through independent pipes. Services are not interfered or attacked. In addition, it inherits the small granularity feature of SDH. OSU Flex technology can support smaller granularity lower than OTN's 1.25 gigabit per second. The minimum granularity can reach 2 megabit per second, the same as that of SDH. Therefore, the right bandwidth can be provided for services with different rates, improving bandwidth utilization. Third, to improve latency performance, OSU Flex optimizes the service encapsulation process compared with the OTN's 5-layer encapsulation process and SDH's 3-layer process. The 2-layer encapsulation capability enables better latency performance. OSU Flex has the strength of both SDH and OTN. It can provide bandwidth of 2 megabit to 100G. The minimum bandwidth and adjustment step can be as small as 2 megabit per second, which can enable high bandwidth utilization. A single 100G channel can be sliced based on the size of services to be carried to meet bandwidth requirements. For example, relay protection services that require real-time control in power production, RE1 services, and require 10 millisecond latency. OSU Flex provides 2 megabit dedicated pipes, and the latency can be shorter than 10 microseconds, so it can meet the 10 millisecond latency requirement of relay protection services. For example, video surveillance services do not require strict latency but require high bandwidth scalability, so configure high bandwidth OSU Flex channels for those services. Currently, several enterprises, including Zhejiang Electric Power Company, are researching on new power communication technologies. Huawei is also investing in R&D in the same direction to promote the standardization of new OTN technologies in the power information communications field. Zhejiang Electric Power Company, Huawei, China Telecom, Power China, and Siemens jointly promoted the initiation of a project in IEEE. After about 8 months of efforts, the IEEE officially approved the project initiation. The project number is P2893. In August 2020, the project kickoff meeting was held, making a solid step forward for the development of power information communications. To promote the standardization of the new OTN technology in the power information communications field, Zhejiang Electric Power Company will work with project team members and partners. The company plans to test and commercially verify the OTN technology in multiple electric power application scenarios to provide solid case studies and data. The new OTN technology is used to build a converged and elastic network, create a secure, high-bearing, self-healing, and high-efficiency private network. Here, we call on more electric power companies to participate in this technology innovation and work together to convert the Chinese technology into an international standard. Thank you.
Le coronavirus Covid-19 qui ravage le monde depuis 2020 a en effet radicalement changé nos vies et aura sans doute un impact de grande envergure. La vie numérique en ligne des individus et des entreprises occupera une part croissante de notre vie. Au fur et à mesure que la transformation numérique de l'industrie se développe dans une certaine mesure, les entreprises développeront leur propre data center.
In the era of intelligence, a wave of digitalization is sweeping through. There is an unprecedented ocean of data. Business volumes have exploded, and enterprises are moving ahead. How to maximize the value of your data center and to make your business more agile? Huawei OptiX Trans DC908, an intelligent DCI product from the optical industry leader, enables intelligent data center interconnection through the medium of light. When the network meets the peaks of the digital waves, witness how it breaks through the transmission limitations. Huawei's unique Super C+L band technology realize 222 wavelengths, and the self-developed OptiX Stream ODSP chip supports 800G each wavelength, realizing massive transmission of 88T on one single fiber, approaching the limits of transmission. When communication technology meets information technology, witness its simple design. Huawei's optical electrical integrated design breaks the limits of innovation. Based on automatic fiber discovery light sensors and other technologies, truly simple one-click deployment can be realized in a shorter time. When light meets intelligence, witness its extraordinary operational power. A dedicated smart chip and the cutting-edge optical sensor creates a future-oriented intelligent operation and maintenance experience. Ensures proactive O&M. Free up your IT staff's time. Liberate your imagination with technology. Promote evolution with innovation. Create your path through the intelligent cloud era. Huawei OptiX Trans DC908.
L'importance des data centers comme échange et stockage de données de base pour les entreprises est évidente. Après une vidéo d'ouverture, je vous invite à suivre M. Maxime Kouchnerov, directeur du laboratoire de communication optique et quantique de Huawei, dans une intervention intitulée Huawei DC OptiX 2.0 Better DCI Evolution.
Hi, my name is Maxime Kouchnerov, and I will talk to you today about Huawei's DC OptiX 2.0 solution. The fourth industrial revolution featuring intelligent technology is coming. It will help build smart cities, improve consumer experiences, and promote the digital transformation of industries in a faster way. As a key engine for the fourth industrial revolution, intelligent technology will promote global advancement and development. Timeliness of data is critical to intelligent technology. Underlying conditions can change rapidly, so the latest data needs to be provided to the AI model to continue driving business value growth. Outdated data affects the value of the model, and it is important to keep the data online and flow smoothly in real time. Data centers are carriers of data and applications. Therefore, establishing real-time and smooth connections for data centers is the key. As digital transformation is running in a faster way, service security and agility requirements drive the transformation of data centers from large data centralization to 2 geographically dispersed parallel data centers, and then to 3 geographically dispersed parallel data centers. Some industries, like over-the-top providers, have widely used distributed architectures with multiple sites. As data is stored and accessed in a distributed manner, data traffic shifts from intra-data center to inter-data centers. With DC cloudification, the topology of data centers interconnection changes from links to networks. Therefore, it's time to focus on data center interconnects, DCI. According to the report, the bandwidth needs for all kinds of industries grow fast, such as finance, government, or OTT. Every 2 years, the traffic among the data centers is doubling. At the same time, the lease fee for bandwidth becomes a heavy burden for enterprises. As an example here, self-built DCI with 100 gigabits per second or higher capacity breaks even in less than a year. So self-built DCI is a new trend, a necessity for enterprises. Traditional WDM DCI solutions are complex and hard to manage. We cannot accept the space leasing fee and fiber leasing fee increase with the same speed of bandwidth required. What's more, most enterprise data centers only have IT or IP engineers. They lack the experience in optical transmission. Complex and slow deployment delays the service rollout. A large number of losses are caused if fiber faults occur. The passive O&M mode hinders engineers. So the key points of self-built DCI should be less space, more bandwidth, and simple O&M. In order to help the enterprise to solve all these issues, as the optical industry leader, Huawei develops the DC OptiX solution. In 2020, we released the 1.0 version, which brought the high integration with 4.8 terabits per rack unit, ultra broadband with maximum of 48 terabits per second per fiber, and simplified operation and maintenance, which brings auto commissioning within 8 minutes. In 2021, the DC OptiX solution is comprehensively updated to version 2.0. With 6.4 terabits per rack unit higher integration design, it can bring 50% space savings to data centers. It achieves a maximum of 88 terabits per second per fiber capacity, bringing 40% more fiber lease saving. In the O&M part, DC OptiX has evolved from automation to intelligence, including fiber health prediction, co-bundling fiber cable detection, and accurate troubleshooting functionalities, so that IT and IP engineers can perform DCI in an easier way. As the key product of the solution, Huawei OptiTrans DC908 was the only award winner in Interop Tokyo 2020 and can revolutionize your data center interconnect. Traditional WDM devices are complex and occupy valuable space resources for storage and computing. Huawei OptiTrans DC908 simplifies WDM devices, similarly shifting from a mainframe to a blade server, and it puts electrical and optical layers in one box with a highly integrated board design, achieving more than 50% space saving. In 2021, thanks to the application of 800G technology, DC908 reaches 6.4 terabits per rack unit with 1.6 terabit per slot capacity, which brings 33% additional space savings to data centers. Huawei is continuously unlocking the bandwidth potential of fiber. In the version 1.0, based on 400G and 600G technology with 6 terahertz super C-band, the DC OptiX solution reaches a maximum of 48 terabits per second per fiber. In the version 2.0, Huawei developed Super C plus L-band technology, and compared with Super C, the spectrum increases by 83% and extends to 11 terahertz, which means it can support a maximum of 220 wavelengths with 50 gigahertz channel spacing or 110 channels with 100 gigahertz channel spacing. With 800G per wavelength technology, the DC OptiX 2.0 solution can achieve a maximum of 88 terabits per second per fiber, bringing 40% more fiber saving. Traditional WDM DCI device O&M is CT-oriented and complex. Complicated fiber connections and more than 14 steps of manual configurations by professional engineers make the DCI deployment the most challenging and slowest part of data center expansion. Normally, it is a bottleneck for service provisioning. In version 1.0, DC OptiX provides IT-oriented and automatic deployment. Due to the high integrated boards, the fiber connections between the boards in a traditional WDM DCI solution have become internal connections inside the board. So very few fiber connections are required. And one-click auto-commissioning functionality can enable IT engineers to finish the DCI deployment within 8 minutes. Further, with the digital optical network technology and intelligent algorithms, DCI is operated and maintained in a proactive way through the DC OptiX 2.0 solution. As an additional benefit, network-level web GUI, which is the lightweight web NMS embedded inside the device, is updated to support Fiber Doctor, providing a built-in and fast fault diagnosis function. So what are exactly intelligent O&M functions in DC OptiX 2.0? What benefits do do they bring us? Let us check the details. The first one is fiber health prediction to enable a proactive O&M on fiber faults. According to statistics, fiber faults account for more than 68% of network faults. When the fiber capacity is greatly increased, we have to ensure that fiber is working well in the DCI system. If packet loss occurs due to optical fiber faults, the storage throughput will decrease greatly and the computing power cannot be utilized. Due to deployment modes and harsh environments, developing faults of the fiber account for more 20 to 50%. These slow-changing, sub-healthy fibers do not cause packet loss immediately, but will easily lead to an obstruction or even disruption of data transmission. In the past, maintenance is performed only after a fault occurs, or the users complain and the sub-healthy fiber cannot be identified in advance. But now, with Huawei's DC OptiX 2.0 solution, this becomes a reality. Gradual degradation of fiber is predictable days or even weeks in advance, and the accuracy rate is 90%. The second one is co-bundling fiber cable detection to identify where the fibers are in the same cable route. Fibers are a dumb resource. For cables that have been laid over many years ago, it will be hard to identify the path because manual recordings of the path are prone to errors. So this function is helpful for protected DCI scenarios where working and protecting fibers should be in different routes, enabling that the protection really can work. All these innovations rely on Huawei's own strength in intelligent technology, which builds an all-around intelligent capability on NMS IMS to NCE. More than 600,000 Huawei optical network devices are deployed in the world, which accumulates rich experience and data for machine learning. With various intelligent algorithms, Huawei developed, such as time series prediction and enhanced logic regression algorithm, the IMS to NCE predicts the risk of faults and specifies fault points in advance based on the changing trend of optical performance. Similarly, based on the embedded optical pulse reflection technology, IMS to NCE is able of making the intelligent analysis on various parameters generated by light transmission in fibers. Through comparison, it provides the function of co-bundling fiber cable detection. And the third one is accurate troubleshooting. On the DCI network, multiple alarms would be generated on a fault. As a result, a large number of alarms are generated on the network, but the root alarms cannot be identified. So many invalid work orders are dispatched. By using the alarm compression function, the NCE uses the hierarchical clustering algorithm to aggregate alarms generated by the same fault into a category based on alarm features, such as time characteristic, topology features, and service features, thereby reducing the number of alarms by more than 95%. In addition, the IMS to NCE uses the supervised sample learning, for example, historical fault experience learning, and uses the neural network algorithm to find root alarms in 3 minutes. As the key product of the DC OptiX 2.0 solution, Huawei OptiX Strand's DC908 has ranked as a leader by Global Data, which is a well-known analyst firm. According to Global Data, DC908 is a leader in 5 key evaluation dimensions. Architecture. After its release, this product was ranked leader for 2 consecutive times by Global Data. It's the only product from the 7 main vendors in the DCI field. As DCI evolves towards mesh networks, in order to ensure the visit efficiency and low latency, in most cases, one-hop direct mesh networking and optical switching with ROADMs is necessary. For traditional ROADM technology, one optical subrack is required in one direction, which occupies a large amount of space. With the full connections in all directions, the fiber connections between boards and racks are obviously complicated. Huawei developed the first all-optical cross-connect, OXC, in the industry. Huawei's OXC firstly introduces optical fiber printing technology to implement all-optical backplane and achieve zero fiber patch cords. Besides that, the board on OXC integrates 5 boards into one to achieve one direction with only one OXC board. OXC greatly simplifies the configuration and fiber connections and can help customers save 90% space and 60% power consumption. With all these features, Huawei DC OptiX provides one-blade benefits to the customers. So far, more than 350 customers from 65 countries have chosen Huawei DC OptiX solution, which included customers coming from various industries, including OTT, ISP, finance, energy, government, and other large enterprises. Huawei's DC OptiX 2.0 solution continuously provides intelligent and reliable DCI for global enterprises. Thank you for your attention.
Les data centers du monde sont en perpétuel développement. C'est pour cela que nous allons parler des produits d'interconnexion de data centers les plus avancés au monde, qui sont en tête dans cet espace. Veuillez accueillir avec moi M. Rajesh Ghai, directeur de la recherche de IDC, qui nous parlera de l'évolution de l'interconnexion des data centers.
Hello. My name is Rajesh Ghai, and I lead IDC's Worldwide Carrier Network Research Program. Today, I'm going to take a look at digital transformation and the impact this is having on a critical piece of enterprise infrastructure that is often overlooked, the data center interconnect. Let's begin by examining where a typical enterprise is today on its digital transformation or DX journey. The goals of DX, as you know, are to use technology to make the business more customer-centric, to give it the requisite agility, the necessary flexibility, the required efficiency, and the innovation that is necessary to make the business more customer-centric. At IDC, we believe the first phase of DX, the experimentation phase, is coming to an end for most enterprises, and they are about to begin the second phase of DX, which we call multiplied innovation. In the first phase, the focus was on building the foundational technologies and the delivery model for digital transformation. It was about digitizing business processes and about building new applications in the cloud. It is about building the foundational data infrastructure in the cloud. The second phase is about building platforms and communities. It's about leveraging new technologies such as artificial intelligence and machine learning on all the new data being generated. It is to develop new insights from the data stores in the clouds to optimize business processes further and to satisfy new and existing customer needs. In other words, the goal is to make the business even more customer-centric, to make it more efficient, to achieve even higher levels of agility, higher levels of flexibility, higher efficiency, and more innovation for the business. So, using artificial intelligence and machine learning are going to be extremely important for the enterprise if it has to succeed in the next phase of digital transformation. And the key to leveraging artificial intelligence and machine learning is to utilize all the data that is being generated by the enterprise in its DX journey and to harness it across the clouds where it is being stored in or processed in. The amount of data that will be generated in the future will grow by orders of magnitude as more business processes get digitized. Due to digital transformation, IDC believes the typical application portfolio within an enterprise will increase 50% over the next 2 years. IDC also believes that as many new apps will be built over the next 4 years as we saw over the past 40 years, a nearly 10x increase in number of apps. All these apps will produce a lot more data that will have to be stored in many more data centers or clouds, including the edge. Almost 60% of news resources will be in new data centers or edge locations as local clouds become a bigger and bigger consideration. These data center or cloud locations did not exist a few years ago. Furthermore, application and data dependencies are expected to rise rapidly. In fact, IDC research suggests that each business application has 4 to 8 application dependencies already. Applications resident in one cloud must seek data stored in other clouds and with the users. These trends imply that data in clouds will increasingly move from one cloud to another. In other words, inter-data center traffic will increase by an order of magnitude over the coming years. So a multi-cloud world is the new normal. A multi-cloud world is the new normal for the enterprise, both currently and in the future. What is also very clear from our discussion today is that the future of enterprise infrastructure involves supporting a significant increase in the magnitude of data managed in the cloud and consequently a very high increase in the inter-data center traffic. As data becomes the lifeblood of the enterprise and as more and more of it is stored in the cloud and as inter-data center traffic increases in terms of both quantity and importance, ensuring data security and compliance of the data is also going to become very important. What will also become very important in certain industries is compliance with regulation, what is being transferred between clouds or data centers. In addition to the rising importance of security and compliance, network performance also becoming a top priority for enterprises as they leverage more data across the clouds and between the cloud data centers. So it must be evident by now that IDC believes that as enterprises enter the multi-cloud world, inter-data center networking will become a core consideration of data center strategy. In fact, our surveys indicate that even now, enterprise IT departments cite networking bandwidth between data centers as the second most important concern in terms of data center operations. The data center interconnect is critical for application and business continuity and for the realization of the multi-cloud vision. The third most cited issue in this survey that we have over here was disaster recovery and business continuity, which also underscores the need for superior data center connectivity and for the enterprise. As you can see, the right data center interconnect technology can play a valuable role here. It can ensure consistent network bandwidth. It can ensure security policies can be applied across the multi-cloud landscape, including on-premise data centers, co-location facilities, and the public clouds that the enterprises now use. So while DCI technology is becoming mission critical, it's also important to make the technology simple to operate and manage, which wasn't the issue in the past. Today, DCI technology is complex and is often a reason why there is downtime in the cloud because of human error. In addition, the data center interconnect also needs to keep the traffic secure, considering inter-data center traffic is becoming mission critical for the success of the business. Besides ease of management and data security, other key enterprise considerations when it comes to data center interconnect technology are network performance and cost. In fact, in this IDC survey that you see over here, security, performance, and costs were the top 3 priorities for enterprises when it comes to building data center interconnect fabrics. Historically, and even today, most enterprises rely on their service provider partners for inter-data center connect infrastructure. However, given how important this critical piece of infrastructure is becoming to the long-term success of enterprises, especially those with data-dependent business models, large enterprises in certain verticals could consider owning it. So why own DCI versus lease it? So why does IDC believe large enterprises in certain verticals should consider owning data center interconnect technology rather than leasing it from service providers? 2 reasons. The potential for higher ROI if you own it, and secondly, control over what is becoming mission-critical infrastructure. Some of the drivers of higher ROI from owning a DCI potentially are faster deployment of the DCI infrastructure. Deployment time can take days instead of months. Ease of operation and management. DCI technology has recently become a lot more easier to manage than it was in the past. Data security and risk reduction. Operational expense savings in terms of lower ongoing expenses of personnel and lease costs. However, it is not just financial or economic reasons that make owning DCI so appealing. Control over this critical infrastructure can enable enterprise to rapidly expand its deployment without relying on a service provider partner. It can allow the enterprise to automate operation and maintenance, identify and troubleshoot faster when they have issues such as downtime. Moreover, with the enterprise in control of the infrastructure, oftentimes there is greater stability in business which guarantees business stability. In fact, self-built DCI can have a higher ROI. Let's examine that. If we compare the costs of owning DCI infrastructure versus the historical option of leasing it from a service provider, IDC believes self-built DCI can have a higher ROI over the horizon of a lease line contract, which typically runs 3 to 5 years. Of course, it depends on what the lease line costs are in the first place, and it can vary by location, by the bandwidth or port speed leased, and the length of the lease contract. Self-built DCI, on the other hand, involves upfront capex and the ongoing expenses of fiber lease and other operating expenses. While there are a range of possibilities in terms of lease line costs which can have an influence on the ROI analysis, IDC believes owning a DCI infrastructure may pay off for some enterprises in 2 to 3 years. Add to it the intangible benefits that control of critical infrastructure brings, and owning this DCI infrastructure suddenly looks very appealing. So let's see which enterprise verticals have the greatest appeal for DCI, of owning the DCI. Which enterprise verticals are likely to have the highest ROI for self-built DCI? In financial services, DX has led to a lot of more apps being hosted in the cloud. These are being accessed by users and customers on their mobile devices. This phenomenon has led to an explosive data and traffic growth between users and the cloud and between clouds. Besides digital transformation, regulation and customer intimacy are also driving the move to the public cloud. These trends are making inter-DCI traffic mission critical. IDC believes the need for reliable, high-bandwidth data center interconnect and the agility and flexibility gained by owning DCI makes owning the DCI infrastructure very appealing in financial services. Similarly, in the public sector vertical, in several countries, data center infrastructure in general is due for a refresh, given it is very siloed and very expensive to manage. Moreover, the data centers store critical data that needs to be secured while on the move between data centers. Having a reliable data center interconnect infrastructure which is controlled and secured by the government or the public sector enterprise is a glowing need. Self-built DCI or self-owned DCI could again provide the solution. Other enterprises where self-built DCI makes sense are over-the-top video and ISPs. At over-the-top video companies, fast-growing demand for streaming video requires faster deployment of data centers, both traditional and distributed edge data centers. What is also required is high-bandwidth reliable connectivity between data centers so that high-performance video traffic can be delivered to users wherever they are located. Interconnections to distributed clouds and edges need to have higher bandwidth and be very reliable. Having the flexibility of owning the DCI infrastructure can be very useful for these businesses, as it allows them to control the user experience that is so critical for these businesses. So just to summarize, enterprises are on a long-term digital transformation journey, which is increasing the amount of data managed by an order of magnitude and compelling them to move to a multi-cloud model. It is becoming increasingly important that they control the data center and inter-data center traffic for greater agility, for greater flexibility, for more efficiency and higher degree of innovation in their business. Owning data center interconnect infrastructure is becoming critical for the achievement of these DX goals for large enterprises. What is interesting to enterprise CIOs is that the growing DCI model, owning the DCI model, can in fact provide a higher ROI than the lease line model for some enterprises. I'll leave you with a final thought. We think some enterprise verticals such as OTT video, finance, government, and ISPs should consider owning their DCI infrastructure and leasing it. Thank you for listening to me today. Have a great day.
Dans la société moderne, les campus sont devenus les unités les plus fondamentales de notre vie. Une communauté familiale, un campus scolaire, un hôtel, un immeuble de bureau, un atelier de production ou un centre commercial sont tous des concepts de campus. Les campus tout optiques nous apportent une vie numérique plus pratique, sécurisée et efficace. Indépendamment de l'accès à l'Internet, les téléphones fixes, la vidéosurveillance, le contrôle de la production et l'apprentissage en ligne, tous sont étroitement liés au campus. Suivons donc une brève vidéo de la vie numérique du campus OptiX de Huawei. Accueillons ensemble le directeur du domaine d'accès ligne de produits entreprise Transmission and Access de Huawei, Monsieur Gavin Chen, qui nous présentera les nouveaux produits Huawei sur le campus Tout Optique.
Hi, this is Gavin Chen from Huawei. I'm delighted to bring you today's topic on the trend of campus. The topic of my speech is optical is the new trend in campus. As we know, digital transformation is a hitting word these days. Almost all the things we do today is basically being digitalized. The mobile phone calls, the transactions in banks, the money we spend in shops. One big advantage of that is efficiency enhancement. Here I will list 3 scenarios as examples. First one, Huawei is a company now with more than 119,000 employees. We are located in separating offices around the world. We are currently being connected with smart office applications everywhere, supported by cloud data centers and broadband network. According to Gallup, the profit margin of the companies using digital office is 21% higher than the average. This is the reason why bosses should consider introducing more smartness into office environment. Second one is factories. Factories is the place where efficiency is emphasized even more. IDC lists in 2018 that 84.9% of manufacturing enterprises are undergoing digital transformation. Volkswagen Smart Factory is a very good case. The production automation rate is up to 90%. Zero error connection enables accurate machine collaboration. Let's take a look at another scenario in medical care. According to Accenture, 66% of medical organizations are building a digital diagnosis system. Now we see new hospitals today are all equipped with smart service systems to provide better care to patients. The essential part of these scenarios is that digital methods will become a must in the development. This is not just a trend, it's a choice that every organization should follow. To support digital transformation, we see that cloud data centers become quite common, especially in campuses of larger scale. Traditional network follows a locally switched pattern, while in the future, the computing and storage must centralize. A cloud-to-terminal traffic pattern could become mainstream. A future campus calls for a simple and easier network architecture. When the vertical network traffic goes up, traditional network cannot handle it well. The aggregation layer of the network becomes bottlenecks, and high bandwidth is needed to support new video streaming conference services. Let's see what kind of network is the best choice in this consideration. Now, let's move to our major topic. We all know 5G as a heated topic, and 5G seems to be capable of anything in any scenario. F5G is the main topic here. Initiated by ETSI organization earlier this year, F5G develops in parallel to the wireless technologies. From the first generation communication with voice, to GSM era, to ultra web and email communication, to mobile internet with LTE technology, we are now in the beginning of a new period, when massive connections enables a larger scale transformation of every industry, in integration with newest trends such as cloud, big data, and AI. F5G is fifth generation fixed network, based on optical network, supporting omnipresent optical connections. This is the foundation of the industrial development. Fiber is of larger coverage, flexible networking capabilities, and most importantly, easy to measure. This is the reason we see many customers are choosing this new technology to solve for their companies, schools, hospitals, and factories. Currently, fiber to the home solution has been implemented in many countries and regions. We believe that in the next few years, optical fiber connection will be deployed in every campus. The campus optics solution is the very typical application of F5G in the campus, or typically we call passive optical LAN technology. Compared with traditional networks, the campus optics solution has great innovations in architecture, evolution, and O&M. Our strategy is one fiber, simple architecture, easy evolution, and intelligent O&M. First, let's talk on the simplified architecture. Passive optical fiber is used to replace the traditional aggregation layer in the campus. The network is simplified into two layers, saving 80% of weak current equipment rooms and 80% of the energy consumption, reduce TCO by 30%. Second, we talk on the easy evolution. Currently, hotspot Wi-Fi 6 service is the construction standard in many new projects. Wi-Fi 6 requires 2.5G or 10G service interfaces. Huawei's solution can handle such requirements very easily. A 50G PON upstream high bandwidth can be expected very soon. Fiber is resistant to corrosion, high and low temperatures, and EMI. The service life of the optical fiber can reach 30 years. In all optical network upgrade, only boards or even optical modules need to be replaced. So, let's discuss the intelligent O&M. Larger campuses has various services. Campus optics can achieve multi-service over one network. ONT plug and play saves much labor cost. Only one aggregation OLT is needed. For example, Huawei's Xi'an R&D Center and Songshan Lake R&D Center are deployed with such solution, and the network runs stably. One network has only one administrator. Huawei's campus optics solution uses NCE to manage the whole network, improving O&M efficiency by 60%. In this part, I will introduce some of the best products we proposed this year. This one is OptiX Star TA63E. This is the first smart industrial ONU empowered by F5G. These products can be applied to industrial scenarios such as video backhaul for transportation, production line network for manufacturing, field network access for oil and gas, and distribution network for power grid. TA63E has 4 features. First, the optical network is green. From the terminal to the data center, all the connection is based on the optical fiber, which is passive and doesn't need to provide power. This saves a lot of effort in finding power source, especially in the outdoor scenarios. Second, the product is very robust. It is designed with RSI 4096 encryption algorithm to achieve super strong security. The computer of today cannot decrypt the data. Third, this product provides dual-link broadband capability is allowed to ensure no blocking data transfer. Finally, for TA63E, it has the capability to support edge computing. Third-party app can be installed to realize more customized functions in industrial scenarios. This is OptiX Star SA92E. We call it our best Wi-Fi 6 partner. You will see that this product is used for the backhaul of this new wireless technology. This product has 3 features. First, it allows zero congestion in data transfer. For the uplink, we can achieve maximally 40G to realize no blocking data transfer of Wi-Fi 6 AP. The user port supports PoE double plus in connection with 10GE port with AP. Second, this product has dual uplink. When one network link fails, the other link takes over. You will not notice any difference in the network performance. We call zero failure. Third, this product has smart capabilities. the ONU product naturally support plug and play. It means the service goes online when the network is powered on. With an open platform, the SA92E supports edge computing abilities to integrate third-party applications. Also, AI is introduced to the OEM process to realize fast and accurate troubleshooting. In summary, the SA92E is designed to perform to the best with Wi-Fi 6 or best partner. With the efforts in the optical industry, the Huawei campus optics solution has been deployed in over 50 countries in scenarios such as education, business complex, airport, and hotels. Up to now, we have a global success footprint with over 1,500 major customers. Some of the customers, including 90-story tall Sky Tower in Australia, Smart University campus in Fudan University, the world-best airport, Singapore Changi Airport, and Train Brand India Taiji Hotels Group. Finally, we observe that optical industry is developing very fast in the past few years. The first technical standard has been released last year. This is a milestone when all the project construction has a blueprint to follow. Last year, Optical Networking Alliance has been established. Currently, more than 40 members has joined in this alliance to promote POL applications in enterprise scenarios. Huawei has been cooperating with more than 50 partners in commercial projects and industrial innovation. We believe that in the coming years, the optical connection will become the basic networking frame in enterprise scenarios, and campus could be better when optical networking takes the lead. That's all for my presentation. Thank you very much.
Notre futur est déterminé par notre présent. La structure de l'évolution contient toujours un plan et un aperçu afin de répondre aux besoins de demain. C'est ce que M. Patrick Filkins, analyste de recherche senior dans l'infrastructure des réseaux mobiles, abordera dans son intervention sous le thème des besoins du réseau Edge, le réseau local passif de domaine et le rapport d'analyse présenté par IDC.
Good day and hello. My name is Patrick Filkins, Senior Research Analyst at IDC covering network infrastructure. Today, I'm joining you to share IDC's views on passive optical LAN, also called POL or POLAN. POLAN is a fiber optic-based network solution designed to help enterprises address today's network transformation challenges, particularly at the campus domain. To start, I will share IDC's view on network transformation as a subsegment of digital transformation and discuss how enterprises, particularly enterprise campuses, can leverage fiber optic networks to support digital transformation trends. These trends include cloud, Wi-Fi 6, and IoT, to name a few. After spending a few minutes discussing DX and how it impacts enterprises, we will spend more time discussing POLAN directly, as it is important to understand how POLAN differs from traditional campus networking solutions, and how POLAN can help address today's enterprise challenges. As such, after this presentation, you will have a good understanding of the issues enterprises face today, what they will face over the next several years. You will also understand how choices related to enterprise campus networks can impact their ability to execute strategically. With that said, let's get started. As noted, we will start by defining what we mean by digital transformation. IDC has taken a broad approach to this exercise, using a stepwise method to examine how enterprises are and will be impacted. At IDC, we commonly encompass our thoughts on the current digital transformation landscape through what we call the third platform. The third platform covers technology trends starting in the early to mid-2000s through today and what we expect to see in the future. It's based on four key pillars. Those include cloud, social, big data, and mobility. These four trends all embody what the third platform is today. Further, we've seen emergence of what IDC calls innovation accelerators. These accelerators include AR/VR, 3D printing, IoT, artificial intelligence, blockchain, robotics, and next-generation security. Also to note, IDC sees most industries moving past simple experimentation with these technologies into what we call multiplied innovation. This means enterprises are increasingly using these tools to enhance operations, differentiate competitively, and position for the future. Well, these are all separate in some regards. They all share one key feature: the need for improved connectivity. Whether application or use case, these accelerators will need a network to support functionality at scale. So let's provide some more context about where we are in the third platform. As you can see, we are in the era of multiplied innovation. The recombinant use of cloud, social, mobile, and big data, which includes things like Wi-Fi 6, Edge IoT, and Edge Cloud, mean enterprises need to ensure these tools run smoothly. Once again, the network becomes the key connector to all these promising endeavors. Now, I'd like to focus solely on the network portion of digital transformation. As noted, digital transformation requires network transformation. As such, network is a foundational layer for enabling secure, scalable, and efficient use of cloud, edge, and IoT applications. Focusing solely on enterprise networking, IDC observes organizations ranging from hotels, utilities, educational campuses, hospitals, and others accelerating their network transformation. This generally means focus on network transformation as it relates to digital transformation, the use of things like Wi-Fi 6 and other access modalities like LTE and 5G, machine learning, AI, network analytics, IoT edge applications and solutions, and cloud networking. As a whole, enterprise networking is becoming more complex, and enterprise networks need to evolve to address many use cases and applications at once. This becomes the main challenge network administrators will address. Said differently, enterprise network solutions need to evolve and also prepare organizations for these long-term changes. Diving deeper, I'd like to quickly discuss 5 key trends impacting enterprise networks today, and as we'll discuss in the following slides, campus networks. First, enterprise networks need to embody centralized control and management. Simply overlaying network and network control systems is not an option. Less networks for single use cases, more network control. Second, enterprise networks need to support more video traffic. In today's COVID-19 environment, more employees are using video applications, which can be hosted on-premise or from the cloud. Mobile employee devices are also increasingly used for video tools. As video continues to proliferate, enterprise networks risk becoming bottlenecks. Third, cloud-managed solutions continue to rise. Organizations increasingly rely on cloud providers to deliver a host of applications and services. This enables organizations to outsource IT. It can create problems if the on-premise network is not upgraded as well. Fourth, Wi-Fi 6 is coming. IDC expects significant ramp in 802.11ax deployments. With new access points expected to scale over the next several years, enterprise campuses will be flooded with new data not only from the cloud, but from end users and end devices. It should be clear now that existing campus networks will be under intense pressure to keep pace to support top-down pressure from the cloud, but also pressure from the end device. And finally, fifth, private LTE and 5G solutions. IDC has observed a number of private cellular rollouts globally. This will only increase. If organizations desire to close campus networks and create private infrastructure, they will need to consider how their on-premise networks adapt to the impact of cellular use cases, such as more mobile devices, cellular IoT, and 5G. As we've discussed the technology problems in depth, it's worth spending a minute or two to touch on the business impact. I will now share with you 2 sets of data, one from an IDC IT strategy survey and another from an IDC survey which discussed enterprise edge networking. The first data set asks, what are the top 3 drivers for placing applications in an edge location? As you can see from the first slide, security is of utmost performance, a common occurrence in almost all enterprise surveys. Well, this is important to note. Look further. Enterprises rate lowering costs and improving latency in the top 2. Also included are drivers such as modernizing infrastructure and IoT. These all relate to the network. I'd also like to read verbatim some of IDC's findings. In 2023, 68% of all data will reside in core edge locations. Again, a potential impact to data creation at the network layer. Now let's look at the second data set. This data set asks, do you agree with the following statements? Statement 1, my organization is supporting far more devices, servers, and application in a remote branch location than ever before. As you can see, 81% of respondents agree that more devices will be placed at the edge, which could be a branch or campus location. Many of these devices will be enabled by Wi-Fi 6 or even 5G. The next one, my organization's networks need to have the flexibility to address the complex business needs in local, remote, or branch locations. 78% agree. And finally, in my organization, intelligence is increasingly pushed to the edge. 68% agree. As a whole, enterprises need to recognize how these technical trends impact business potential, and conversely, how business drivers can have an impact on the network. So far, we've covered digital transformation and IDC's view on third platform, how enterprises are viewing their network as a tool to address these changes, specific technologies such as cloud, Wi-Fi 6, and IoT. Now, I'd like to shift the discussion to a specific network architecture which is designed to address these trends. That solution, as noted, is POLAN. In discussing POLAN, we will cover what POLAN is, the expected benefits, and how it can help solve today and tomorrow's use cases. As noted, POLAN is a fiber optic-based solution for enterprise campus networks. It borrows many of the characteristics from service provider gigabit passive optical networks, or GPON, but is form-fitted for enterprise campuses. This includes the ability to house network infrastructure within indoor closets, walls, and ceilings to accommodate the unique environment enterprise verticals require and enable organizations to extend fiber as close as possible to the endpoint. POL consists of an optical line terminal, PON splitter, and a series of optical network units, ONUs, all connected by single-mode fiber. This architecture is proving to be a stronger solution across a number of metrics, particularly in greenfield environments, such as a new commercial building, hotel, or university campus. As we discuss POLAN in comparison to other market solutions, such as Ethernet access, it's useful to compare them side by side to understand some of the benefits POLAN can provide, and why you should consider it when deploying a campus network. Let's compare POLAN to traditional Ethernet access in a graphic. Using this graphic, we can see that POLAN aligns closely to existing architectures, including placing OLTs in the data center campus core domain, PON splitters in a campus network building itself, and then ONUs in the individual room or wiring closet. The ONU can then either enable fiber to the endpoint or support Power over Ethernet, PoE, which can connect to both wired and wireless access points. Traditional Ethernet access also places switches at the data center campus core and individual room wiring closet, but often requires aggregation switches in the building as well. This can result in more spend on traditional network infrastructure in comparison to POLAN. In the case of POLAN, the use of single-mode fiber enables enterprises to deploy network infrastructure further apart, as opposed to the traditional use of Cat5 or Cat6 copper cabling. As such, the impact can be substantial across a POL deployment, as the front-end costs of deploying network infrastructure to supporting and maintaining that infrastructure are reduced. Further, having less electronics means less energy usage, reducing day-to-day costs. Overall, the key takeaway is POL can result in a lower total cost of operation in comparison to traditional Ethernet access. Let's take a look now at some other benefits Pole can provide. First, fiber optics can enhance LAN bandwidth both today and future-proof for tomorrow. In the case of Wi-Fi 6, enterprises are likely to need at least a 10 gigabit backhaul solution. Pole can surpass that easily, shielding enterprises from the potential network bottlenecks Wi-Fi 6 may produce. Second, fiber optics technology can help to improve application performance, regardless of where the application is deployed, which could be in the cloud, at the core, or an edge location. Third, PoleLAN supports the concept of a single network for multiple use cases, with a centralized management on top. Centralized management is required for most enterprises as a means to reduce network complexity and improve overall operations. Fourth, as noted, PoleLAN can reduce energy expenditure. In many regions, new building codes are pressuring building owners to adapt to stricter, greener energy requirements. In the case of greenfield builds, IDC supports the notion that more building owners are becoming interested in PoleLAN as a means to meet stricter codes by reducing energy output from less electronics and less copper cabling. Finally, PoleLAN can help reduce overall CapEx and OpEx. As noted, less electronics reduces upfront costs, while also reducing day-to-day spend on power and maintenance. Now, let's examine how Pole is being deployed across some enterprise verticals. In each instance, Pole aligns nicely to the unique demands from each use case. In today's call, we'd like to highlight how Pole is positively impacting specific verticals. They are hotels, universities, hospitals, and government buildings. In the case of hotels, Pole networks are being deployed to handle all potential use cases on a single network. This includes room services, like wireless broadband, TV, and telephony, as well as smart building automation such as elevators, kiosks, smart signage, and door locks. Further, PoleLAN is being deployed to handle the traditional back-office IT required on-premise in a hotel. Once again, Pole addresses all these use cases at once. In the case of university campuses, Pole is viewed as a safer solution and enables the connecting of office, dormitory, athletic, and food venues, all with their own unique needs across network performance. Government centers also are looking more closely at Pole as a means to connect sprawling campuses, which may require different things from the network depending on the use case. Finally, hospitals in select regions are beginning to look more favorably on Pole. For example, one use case is CT imaging, whereby a Pole network provides near real-time sharing of images, helping improve patient care. Said differently, as all verticals undertake their own transformation initiatives, which includes expanding across a number of use cases, the network needs to be ready for any potential scenario. In closing, IDC would like to provide some guidance to all enterprise customers and those considering how they will upgrade their campus networks to meet these future needs. First, define your network transformation goals in the context of broader digital transformation. Your use cases and applications can help to define your network needs. While Pole is designed to address most use cases and scenarios, it is important to not lose sight of what your network is trying to support. Second, network transformation is becoming very broad, encompassing many technologies including machine learning, artificial intelligence, network analytics, cloud, Wi-Fi 6, IoT edge, and big data. The network needs to become more simple than a pipe, but a future-proof tool capable of delivering on performance, but also intelligence. Third, in comparison to traditional architecture, Pole has the potential to reduce both upfront and day-to-day costs. And finally, in the case of greenfield builds, PoleLAN should be considered, as it can help building owners align to increasingly strict energy codes. That concludes today's presentation. Thank you.
Passons à présent au tirage au sort de Huawei Afrique du Nord, où nous allons annoncer 10 gagnants chanceux. Bon courage à tous. Félicitations à tous les gagnants. L'équipe de Huawei Afrique du Nord vous contactera bientôt pour récupérer votre cadeau. Chers invités, mesdames et messieurs, Huawei Afrique du Nord OptiX Club arrive à sa fin, en espérant que vous avez tous passé du bon moment. Si vous voulez plus de détails sur les nouveaux produits et technologies que Huawei a introduits aujourd'hui, vous pouvez nous joindre par l'email affiché dans la boîte de discussion. Nous vous contacterons dès possible pour plus d'explications. Merci de votre participation et bonne journée.